All right, fantastic. Well, with that, I am really excited to welcome up the panelists for our first panel of the symposium. We're going to be talking about lunar exploration, and we've got a fantastic group of experts to talk about the moon and what is happening now and what is going to be happening in the future. So with that, I would love to invite up Bethany, Gerard, Ricardo, John, and Yusuke-san to join us up on stage. Thank you so much.
All right. Is this one hot? Okay, now it is. Great. Well, so I have the delight of moderating this fine collection of folks to talk about U.S. and Japan collaboration in space, specifically at the moon, which is, of course, a very exciting place to be. And as a way of just motivating that, I put, three photos or images up here of current or perhaps upcoming events. One is out of Caltech, and I am the principal investigator, and then managed by JPL, the upcoming Lunar Trailblazer mission launching in February 26th, the evening of February 26th, the small satellite to map the form distribution of water on the moon. That is a small satellite operated out of the Caltech campus. So universities doing space exploration. In the middle, we already heard about all of the excitement of landers at the moon. That includes the precision landing of SLIM. And not only did it land very close to the target, but actually it also survived multiple cycles through the lunar night, which is no small feat. The moon is a challenging environment. It's boiling hot near the equator during the day, and then at night incredibly cold. And it's a 14-day night. Remember, the moon is... So this was a great accomplishment. And then, of course, the dreams of the future. Humans on the moon, a permanent presence. So there's a lot going on in science and exploration, and I'm thrilled for our panel to talk about it. So if I hand the clicker over here to our first panelist, who is Gerard van Belle, who is the Director of Science at Lowell Observatory, for his remarks.
Thank you, Bethany. I appreciate that. I appreciate the speakers that have introduced us to this point. I especially liked General Consul Sone's remarks, and I appreciated the reference to space battleship Yamamoto, which inspired me as a child as well, better known in the US as Star Blazers. And this, for those of you that aren't familiar, this is an intrepid group of explorers that set out into the cosmos to explore and to save the Earth. And I've always tried to bring that to the work that I've done, to be very intrepid and very audacious in the things that I've done. And one of the things that led us to was this KISS workshop that was hosted by Harriet and by Bethany to talk about observational telescopes that we could put on the lunar surface. With the thoughts of returning to the moon that have come and gone over the past few decades, one of the things that people have been negative about is the prospects for putting observatories on the moon. So it was observed a couple of decades ago that all that the moon has to offer is dust and gravity. Now, I'm here to talk about that, to point out that the dust is not a problem. We have an existence proof that you can put telescopes on the moon and operate them for years. Was the case of this particular one that landed in about 2015 and operated for many years. And so you can actually get around the dust problem. And the other thing is that gravity is not a bug, it is a feature. It lets you put things down and have them stay put. And so in the example of Surveyor 3 and Apollo 12, they have been 180 meters apart from each other for the last 50 years and have not moved at all without even trying. And so for somebody like me that builds arrays of telescopes to synthesize optical systems that are an order of magnitude bigger than you can build with, say, JWST, and still get high levels of sensitivity. I'm very interested in the lunar surface as a place to put telescopes and come up with very high-resolution observations that let us explore the cosmos and see planets around other stars and measure their masses and help lend these discoveries towards finding life on those planets. So with that in mind, we had a KISS workshop here in the middle of November. KISS workshops, if you're not familiar with that, you bring together a group of about 30 world experts that want to talk about the subject. So in this case, we had about half of us being telescope designer types like myself, and then half the other people were lunar experts. And when you run a KISS workshop, you want the very best in the world. I was very happy to have two of my colleagues from Japan join us, Takahiro Ito and Taro Matsuo came to talk about their experience with working on telescope arrays and with landing SLIM on the moon. And so these are systems that are now in place, and the expanding lunar infrastructure will let us do these kinds of things and build these kind of telescopes and put in systems that let us have brand new optical systems of an unprecedented level of resolution. This is a small example. We have something called Moonlight that would go with, if you get handed a rover and get handed a lander, we can actually come up with a demonstration system that would be a pioneer of doing these kind of, a family of these kind of observatories on the moon. And we are very excited to try and build collaborations that will let us come up with these systems and start small and then work very, very large as we add things and add telescopes to these arrays of telescopes that would let us see with very fine, exquisite detail things in the cosmos. And so with that, I think I'll hand it over to my next panelist here.
Okay, and so our next panelist is Ricardo Woodbury, who is the Executive Vice President of Finance, Accounting, and IIT for ispace, US.
Yes, thank you very much for that, Bethany. First, I want to echo the comments from earlier. I'm not from the LA area. I flew in from Denver yesterday, and although there's been global coverage of the devastating events that have been happening here, it really is heartbreaking to see it firsthand. And just do know that my thoughts are with you. With that, I do appreciate that the Keck Institute for Space Studies and the Consulate General of Japan here in LA have worked tirelessly to continue and put this event on. And lastly, I do, as I was leaving for this event, my 5-year-old daughter, Isabella, begged me to take her with me. She has become quite the space enthusiast in her short time here on Earth, and it broke my heart to tell her no, but we did agree that school is yet the most important thing. So what is ispace? So ispace is a lunar resource development company. We are focusing our efforts on lunar landers, so descent vehicles, as well as surface rovers. And when I was invited to come to speak to you all today, the first slide that came to mind was this, simply because it really showcases our collaboration between our two nations. We do have a third national presence, which is in Luxembourg, and Luxembourg focuses on developing our rovers. As you can see on sort of the left-hand side of our slide here, our Japan entity is operating our first two missions, Mission 1 and Mission 2, which is really the research and development phase of our company. And this is more or less our proof of concept. We then kind of transition as we move to the right in time. We have a Series 2 lander, which is known as Apex 1.0. That is being developed in Denver, Colorado by our US team and is in conjunction with Draper Laboratory to participate at the CP12 task order under the CLIPS program, which for those of you who don't know that acronym, it's the Commercial Lunar Payload Service. As we continue to move to the right, you can see, we have Mission 4 and 5 and 6 planned, with eventually moving Mission 6 back to Japan for our Series 3 lander, which is yet another iteration of our large-scale landers. With that, I do have to mention that this is a very exciting time for my company because just last Wednesday, we launched our second mission successfully. And thank you so much. We're all really excited. We're all very exhausted as well, but so far, so good. And I think maybe we'll talk a little bit about that later, but I think I'll hand it off here to John.
Great, thank you. So our next panelist is John Baker, who is at JPL and the manager of lunar and low-cost projects.
Good afternoon. I'm happy to be here, and thank you for the invitation. Let's see. So, clicker, great. I wanted to say a little bit about my views of the moon and why it's important to us as a society, as a global society. When I was younger, I watched the Apollo program go on and astronauts walking on the moon, and immediately realized that, hey, we've been to the moon, we've explored it, we've brought samples back, and everything we know about the moon, it seems to be basically kind of the same, right? And this was the perspective many decades ago. That perspective has started to change a little bit, but there's still a lot of the, we've been to the moon, we know what's there, unless you're a scientist, no offense, Bethany, but there's, it's really like we kind of already know that, right? We already know what's there. But as we started, so in 2004, I was invited to go to NASA headquarters, and I was responsible for getting the Lunar Reconnaissance Orbiter going and that mission going, and we had to sell the mission to Congress. And Congress themselves was very interested, but yeah, we've kind of been there already, we already know everything that's there, and why would we do another mission and spend taxpayer dollars on this? So in that process, I had to do a lot of research to find out what we knew and what we didn't know. And it became really apparent to me and to eventually to Congress that there was a lot we needed to explore the moon. And eventually, LRO got started, and the mission is still flying today. And LRO by itself has really made some remarkable discoveries. So it launched in 2009, and it's still operating in 2024. We found one of the coldest places in the solar system at 20 Kelvin on the south pole of the moon. We have high-resolution images and maps of all over the moon now. We have resource maps. So yes, the moon is not really homogeneous. It's very heterogeneous depending on where you go. And so lots of amazing discoveries like that as we were forming it would become the foundation for formation. As we were formulating the mission would become the baseline and enabling for future exploration. So, and that it has, as you see in our exploration efforts today. So, but as the moon comes and goes through different administrations, so we really thought about how do you do more sustainable lunar exploration? Well, the obvious answer from our Congress was make it cheaper. And so we noticed that JAXA had done the Procyon mission and had launched a small satellite to deep space. And we're like, that's very interesting. So we had a mission called Marco that we launched in 2018. And these were the first 2 CubeSats to go all the way to Mars. And we really had to change our perspective about could CubeSats, in theory, CubeSats like small satellites, literally, briefcase size, could go all the way to Mars, but we had never done it before. So we actually did it successfully, and then on the heels of that, NASA created the Simplex program, and I'll talk more about that. And so the Simplex program, one of the first winners was Lunar Trailblazer. So I've talked to you a little bit about LRO, but and Bethany has mentioned Trailblazer. Trailblazer, of course, is going to launch at the end of February on the 26th. And it was really one of the first scientific pioneering low-cost missions to better understand the water cycle at the moon. And as we have continued to think about how do we explore the moon, we started thinking about other ways that we could do it. And what were the other really key questions that the moon could answer, key scientific questions that the moon could answer? So it turns out there's quite a few. For example, we really don't know how old the moon is. How old is our moon? How was it involved in the formation of the Earth and the moon system together? How did they evolve together? And I'll say a little bit more about that. But just to finish, we have Cadre, which are some small lunar rovers that we're launching next year on an ispace lander. We have the Farside Seismic Suite, which is actually Cardria is going on Intuitive Machines. Farsight Seismic Seed is going on the ispace lander. So we have a number of engagements with the commercial lunar community, and so far they've been very productive. So with that, I wanted to just give so this kind of leads us to the scientific interest and the technology interest in the moon, and I'll say a little bit about that. The moon has an impact basin on the far side called the South Pelican Basin, and it's one of the oldest impact basins that we know of in the solar system. And from that impact basin, we may be able to understand more about the origin and evolution of our own solar system. The moon, because it doesn't have an atmosphere, is a great archive for the solar system history. And I think also about the same time as the impact of whatever hit the moon and created this impact basin, we'll be able to understand perhaps more about the conditions of the solar system at that time and when life may have originated here on Earth. So with that, we've been formulating, and thanks to the National Academy of Sciences, there were quite a few studies done to what could we do that would be scientifically very compelling to fundamentally alter our understanding of the solar system, to fundamentally understand more about our own Earth-Moon system. And that was one of the studies that was recommended by the National Academies, was called the Endurance Mission. So we're currently formulating this mission at NASA, at JPL, with NASA's support right now. And in fact, I know there's some JAXA involvement in the science definition team. Thank you very much for your support. We look forward to working with them on the team. And so I think with that, I think just to say a little bit more about Endurance, and then I'll hand it off. Endurance itself is a fully autonomous rover. It's a rover that is going to be designed to drive thousands of kilometers to not only just capture samples throughout lots of different terrain, different and diverse terrains on the far side of the moon, but also to explore the whole moon and tell us a lot more about the side of the moon that we don't see and the moon itself. So I think with that, and then finally the last key point on this is that the Endurance will be done because of our cooperation with robots and astronauts working together.
Great. Thank you, John. And then our final panelist is Yusuke Kajiwara from Toyota Motor Corporation. And at Toyota, he is the S&MA QMS manager for the Advanced Space Mobility Development Division. So, Kaji-san.
Thank you. I am Yusuke Kajiwara from Toyota, Safety and Mission Assurance and Quality Management System Manager for Pressurized Rover Project. First of all, I'm so sorry to hear about the wildfire at this time. But thank you for having me today. This is a great opportunity for us, Toyota, and also myself to share our project. Without further ado, let me show you the video first. This is written in Japanese. Our challenge is for human and society and for our futures. Yep, this is the appearance of our pressurized rover. 6.3 meter length and 4.7 meter wide and 4.9 meter height. And 2 crews will stay about a month for crewed mission, and rest of 11 months uncrewed mission will be performed. Manual control, remote control from ground, or by autonomous driving is available. Regenerative fuel cell system will make oxygen and hydrogen during the daytime through the solar array panel, with using only water and sunlight, and use fuel cell to supply the electricity in the nighttime. total of 10 years of life, and 10,000 kilometer driving is to be achieved. As you see, this is the this was created by computer graphics. However, this will happen in the real world. Thank you. Oops, I may have some more slides, which has already been covered by Wada-san, but let me explain a little bit more. This project is part of Artemis program, which is led by NASA. So this is the US-Japan collaboration itself, I believe. Mobility for wide area exploration is important for sustainable lunar surface activities, and as Wada-san said, international agreement was made April last year, and Japanese government agreed to provide a pressurized rover, and Japanese astronaut will have an opportunity to be on the moon twice. Yeah, this is too excited for us. And we, Toyota, will contribute developing pressurized rover with JAXA. Yep, Toyota, our corporate mission is producing happiness for all. The technology improvement through the pressurized rover, we call, there is 4 key technologies, which we call off-road driving performance, autonomous off-road driving, and regenerative fuel cell, and user experience. Those technologies will be brought back to the Earth. And we'd like to contribute society and new kind of city and car making. Our mission is development of pressurized rover we call Lunar Cruiser is the most important mission for our division, but not only that. We'd like to feed back our technology, our key technologies back to the Earth. We call from Lunar Cruiser. And we will utilize the technology in the space industry, we call with Lunar Cruiser. And as for beyond the Lunar Cruiser, we'd like to challenge the next generation of lunar mobility or space mobility, which is maybe lunar bulldozer or lunar bus or for sightseeing, or even lunar school bus for our grandkids or great-grandkids. Yep, this is a future expanse with our pressurized rover. We are thinking about how we use the technology back to the Earth. Yep, that is my, that's all for my presentation. Thank you very much.
Okay, thank you very much to our panelists. At this point, we have about 25 minutes for questions, and there's a QR code there that if you point your phone and you don't take a picture of our panel, but you point it at the QR code, you can pull up the questions. And Harriet is giving me the page here where questions are appearing. Let me, as you populate with some questions, let me go ahead and ask one very obvious follow-on, which is, Ricardo, how's ispace doing right now on the way to the moon? So you launched, maybe you can say a little bit about how the mission that is in space right now is performing. What should we look forward to in the weeks and months to come?
Yeah, absolutely. As I mentioned, and you mentioned as well, that, yeah, we did launch successfully last Wednesday. Super exciting times for us. And we were fortunate enough to have Yamazaki-san, who spoke just before this, there in support and watching with us. And yes, we have defined 10 milestones on our journey here, and we've already completed 4 of them. The 4th one, which was completed most recently, was our first orbital control maneuver. It was a perfect success, and we've continued on. And milestone 5 is actually our lunar flyby. and after which we begin our officially deep space operations. Because we're on a low energy orbit to the lunar surface, we don't anticipate landing until somewhere in the first week of June, but so it's quite a long path to get there. But so far everything has gone just phenomenally well, maybe almost too well, especially for space activity. So we're really excited. We have already begun getting back telemetry data from both the spacecraft itself as well as some of our payloads. And we've gotten some images back. And if you're so interested, please stay tuned to our social media, because we are getting those out to the public as quickly as we possibly can. Pictures and milestones and such. So.
Can you talk a little bit at arrival at the moon? What will the lander do once landed?
Yeah, absolutely. We have several different payloads, but one of the really cool payloads that I like is we have a deep space radiation probe. And the reason that I really like this one is it's actually a student-led development. Both design, develop, and qualification of this payload was done by a group of students out of the Central University of Taiwan, and it's basically measuring radiation data in and outside the Van Allen belts, in deep space, and then on the lunar surface, so that we can collect this data and use it for future spacecraft development, infrastructure development, what have you. We also do have a rover that is in transit now, which was built in our Luxembourg office, known as Tenacious, and it will also be carrying a few payloads of itself. So one of them is a scoop that will essentially pick up lunar regolith, and it'll then take a picture of that and eventually, hopefully, sell that regolith to NASA. So, lastly, we do have a really interesting payload, which is more of an artistic piece. It's a Swedish house. It's a model, and that house is going to be then placed on the surface.
Does it have to be built like an IKEA thing?
With some assembly required?
It is assembled, I assure you. But yeah, that's where we stand right now, and we're really excited to just keep moving forward.
Okay, great. And I wanted to speak to Kaji-san about the Toyota rover a little bit. Can you talk about, maybe at a little bit more detail, how do we think about Toyota's engineering principles? And how do you I mean, typically Toyota is making, millions of cars. How do you apply the engineering principles of Toyota toward the making of the lunar rover?
Okay. Toyota's engineering principles are utilized developing pressurized rover, of course. And you know about the Land Cruiser? You know?
The Toyota Land
Toyota
Cruiser?
Land Cruiser,
Yeah.
It's one of our flagship vehicle. The philosophy of Land Cruiser is go anywhere and always come back safely. So this reminds us the safety is a top priority. This is the reason why we call pressurized rover Lunar Cruiser in Toyota.
Very good. And just some folks on the audience want to know, how does the Toyota rover get to the moon? Is it delivered by a landing system?
Sorry, I couldn't answer because that is decided by NASA and JAXA.
Okay, as to which landing system?
For me to...
Which landing system? Okay, I understand. But the answer is yes, it is a separate landing system. Yeah, but which one is to be determined?
I want to answer about... Sorry.
I'd like it to be an ispace
I understand.
lander, but.
I understand. Gerard, do you want to talk a little bit about some of the benefits of being on the surface, or say a little bit more?
I was going to say that highlights one of the things that's an interesting opportunity here is that so much of this is basically a contractual service where, I want to put a telescope on the moon. I've talked to NASA. NASA basically goes out and finds Eclipse lander for me. Or, if you want to put a rover on the moon, this infrastructure is getting built up and put into place so that it facilitates activities on the moon, scientific research on the moon, international cooperation on the moon. And so this has been a very exciting time.
Yeah, and maybe you and actually anyone on the panel now can talk to this. What do you see as the opportunities for collaboration between scientific and engineering institutions like Caltech, government space agencies, commercial companies? Can you speak to what each of you sees as the opportunities for collaboration, in particular US-Japan, of course?
So I can start off with that. I mean, there's a long tradition of that in astrophysics, of building things collaboratively and having missions that explore the cosmos, but do so in a quasi-diplomatic way. JWST is a good example of this, of many parts from many different countries. And these sorts of systems now that are getting put into place to make lunar exploration happen are being provided across many nationalities and provide, together a collection of tools that let us utilize and make use of the unique environment of the moon. From my standpoint, I can take systems that work really well here on Earth but are transformed when you put them on the moon, and can take advantage of the fact that there's no atmosphere above your telescope. That to me is really important, that we can work together to come up with these kind of systems. And so that's the opportunity that I see, and that's one of the things that we tried to bake into this KISS workshop, and we'll do so with projects going forward as well.
Yeah, does anyone else want to talk about the unique collaboration opportunities, US-Japan, commercial, academic? Yeah, Kaji-san.
Yeah, we believe Toyota, this is first time for us to develop the space mobility. So we believe building partnership is extremely important, and research institution like Caltech may lead advanced research and technological development by collaborating with our company like Toyota. For example, I believe it will also be necessary to conduct the tests that simulate the space environment. We don't have such kind of the equipment at Toyota. So maybe we can use, or we can get the data from JPL or Caltech. That is really important for us. So, and it will be also appreciated if we can collaborate with Caltech and learn from your tons of experience for the lunar exploration.
Yeah, and I think during this sort of nascent phase of moon exploration, I think right now we're in the sort of data collection phase. We're working on trying to figure out how do we go from where we are today to actually building infrastructure, and I think that's a perfect, my example already of the Taiwanese payload that we're flying currently on M2. That's a great example of how we can collaborate. Kind of transitioning to cross-nation collaboration. I think right now, as a global company, ispace has three entities, and while our U.S. entity is very much sort of U.S.-based employees, and that's mainly due to export control reasons. Our Japan entity hires employees from all over the globe. I think we have over 20 nations represented in that office, and that's really pushed us as a company to just think more globally. Not only talent, but supply chains and suppliers and materials, and just bringing all of that together.
Like, take a shot at it?
Take a shot at it.
So I think at least for the future activities that we are doing, beyond what we've already done with JAXA, I think there's on the Endurance mission, the science definition team participation could lead to payloads, science payloads. JAXA has very good planetary scientists and also knowledge and experience with the moon. So I think there's an opportunity to participate in the Endurance mission in that way, and there could be engineering opportunities as well. We are still formulating, and NASA has been very open about welcoming international participation on the Endurance mission. So open to more discussion on that.
Yeah, that's great. And I'll maybe offer my opinion as well, because one of the things I've always admired about the space missions from Japan, especially recently, the Hayabusa missions to do sample return from asteroids, the SLIM lander to the moon, in addition to the main lander or orbiter or sample return vehicle, there are also all these other little interesting craft. Like Hayabusa had these hard landers that basically bounced to the surface and then were able to take pictures, or a micro rover. And I know that SLIM, it sort of ejected out a camera system that was actually based on a toy, but hosted cameras that were then able to take pictures of the lander. So I think there's a creativity as well that I have always admired in the science missions of JAXA, and I hope that feeds forward as U.S. industry continues, as NASA continues, this nimbleness and creativity in terms of how the partnerings are made to bring additional technology along. Maybe one of the questions that I am getting online, can you discuss the role of robots versus humans on the moon? Robots and humans. So to what extent can we do our science objectives with telescopes with robots, or do we need humans, or is it a mix? To what extent can we answer science questions and do JPL-style exploration? How does ispace think about this? How does Toyota think about this? Humans and robots. Who wants to talk about how we envision the future?
I can jump in to start on that. Certainly, robots are a great place to start. With humans, when you get to that point, you have greater requirements for mass down to the surface, for power, for survive the night, that drive these requirements. And so the presence of humans helps pull a lot of that along and helps you be more ambitious in scope. Humans are big, dirty, nasty things that kick up dust, and so for telescopes,
you don't like
it can
dust.
be a problem. But they can also carry things around and set telescopes down in very specific points, and so it's a certain give and take. With a roadmap that involves telescope systems developed for the surface of the moon, I see a family of systems starting off very small that are robotically deployed, and then potentially things down the road that are human deployed and human maintained. One interesting thing that comes out of having the human presence there is perhaps you can be a little less stringent about multiple lines of redundancy. When things break, you can go fix them. We've seen that with Hubble, that having humans in the loop to, on an occasional basis, come and fix things has been very helpful. And so I think that there is definitely a role for that, and a certain number of capabilities that come along with the humans that is very, very useful.
Humans, of course, are much more time efficient in making decisions in situ and able to do much more complex tasks in a timely fashion. Robots, however, can go into much more dangerous locations. Even though it takes longer, they can take more risk than it would be for an astronaut. For example, going into a region that has steep slopes, or a
dropping into a lava tube. Maybe you want to send the robot first.
That's right. Yeah, dropping into a lava tube would be good to send a robot first. So those are really practical. I think also we've been giving it a lot of thought on endurance, and I think there's an opportunity for astronauts to be more involved in what samples, even though the rover collected a bunch of samples, what samples should be brought back for additional analysis here on Earth.
Yeah, I completely agree with Johnson. As I said, the safety is a top priority. So I'm sorry to the robot, but please go ahead. Robot first.
Robots go first. Yeah. Well, we're paving the way now with many of the robotic missions, right? And collecting the key information to get to the moon. There's one question that is getting the most votes, and people who are voting for that question, I'm leaving it to the end, because it transitions to the next panel very nicely. But the second question is, I'll maybe tweak it a little bit. What is the one thing that each of you wishes you knew about the moon? What is a big question that you wish you knew the answer to? It can be a science question, or it could be a technology question. Is there some big burning question that you think is very important that we should know about the moon as we embark on this new era of exploration? What's the big question in your opinion?
I have two.
Okay, you can have two.
One is, how old is the moon?
Okay.
Right?
Yeah.
And that I think we can accomplish with the Endurance mission as well. And some of the Artemis missions as well that could be complementary to
Like collecting samples and
collecting samples and bringing them back. My program scientist, James Keane, and I have been thinking about how do you do that? How do you complement what Artemis is already doing with Endurance, and how do they play against each other? The second question is really, so how old is the moon? I think we've not explored the moon enough to really know everything about it. And if you're driving a long distance, I suspect there may be we have this nagging question in the back of our minds, even on Endurance. Are there types of terrains that may be difficult to traverse that we don't know about today? And so that is one of the things I lose sleep over.
To kind of add to that, I think my question really is how livable is the moon? I mean, one of ispace's goals is to establish a permanent human presence by the year 2040, and so to kind of go off your question of how livable or how manageable is that terrain? Is this something that we really can accomplish? And then what, if it's not so easy, what do we need to know in order to cross that barrier?
I have a pretty technical thing that I want to know, which is what is the vibration environment of the surface of the moon for putting very sensitive telescopes on the moon. And so one of the things that's interesting about it is we already know the answer to that pretty well from the Apollo missions. We know that it's actually pretty insanely good, but
like quiet because, okay, to be clear, Gerard wants his array of telescopes not to vibrate.
that's right.
So that they can create a big interferometer and look at stars in detail, right?
I want to know what the
they don't want to vibrate.
Yes, I want to know what the stability is at the nanometer to picometer level. And so the data has been collected from, say, the Apollo seismology instruments, and it tells us that it's great, that it's really good for some of the advanced telescopes we want to put there, but it is possibly and probably even better than that, and we can probably even push the envelope to make even more sensitive instruments, to make more fine measurements to detect planets around nearby stars and in further masses. That probably is going to be possible, and it'll be coming from missions that are coming up that have new advanced seismometers. The data that we do have from Apollo just has a lower threshold at this point, but we'll be getting these answers, which is very exciting. It's a very geology-centric question to make astronomy possible.
Geophysics, get the physicists working with the astronomers.
Yeah, I just want to ask who's going to be I believe our pressurized rover is needed for permanent presence on the moon. So 50 years later, my pressurized rover is there, or my grandkids is there. That is what I want to ask to the moon.
A good question, a good question. Well, many people in the audience want to know, as these missions are conducted, how are the data being made publicly available? Are you sharing the data from the missions that are going on? I can say for the Lunar Trailblazer project, that's a JPL project that's going to go, all of our data become publicly available within 3 months, and within 24 hours, we put all of our images on the website in quick look version with the calibrated in 3 months. So that's a NASA standard. But how are the other missions sharing data?
The intent for us with anything we would fly would be pretty immediate sharing as well through a center like the IPAC Center here at Caltech. And yeah, making it widely known as soon as possible. That's where you get the greatest scientific use out of that.
Any other comments?
Yeah, for us, I mean, we're flying both government and commercial payloads. So of course, on the commercial side, we have to respect the wishes of our customers. But on the government side, I mean, it's generally quite quickly, I would imagine. And
then the final question, which has gotten so many votes. but I'm going to tweak it a little bit. So the recent buzz announcement in space was the "we're going to Mars," right, type announcement of the new administration. How does that relate to what we are doing and planning on the moon right now? Net positive, net negative? How does the moon feed into Mars? Talk about, and this feeds into the next panel, right, which is beyond the Earth-Moon system. But I'd like the lunar-focused people to talk about how does what we're doing on the moon now relate to any plans for Mars in the future?
Many, many ways.
Many ways, okay.
From a commercial industry standpoint and bringing commercial industry up to the point where we can rely on them for, reliably delivering payloads to the surface of the moon. And then that's a big step towards going to Mars. The same thing with some of the technologies we need to enable longer-term, broader explorations of Mars, like autonomy and autonomous driving, to the reliability. This is my safety and mission assurance hat on. The reliability of these systems to go the kind of distances to Mars and back has yet to be demonstrated for those class of missions. So I know NASA and many companies are working on improving the reliability, but I think going to the moon is really essential because it's so close to Earth, and making sure we're grounded and have a safe way of getting to Mars and back.
I mean, my view on that is Mars is inevitable. The moon is unavoidable. You have to go to the moon first.
So we're doing both.
That's right. You have to do the moon first because you have to figure how to do that before you can go. You got to be able to go 3 days out before you want to go 3 months out.
Yeah, I would agree. I mean, the moon is a proving ground for all this technology, and going back to safety. I mean, if we're going to talk about human presence on another planetary body, I mean, obviously, it's much safer to be 3 days away than 3 months away if something were to happen.
This is a difficult question for Toyota because we have been contracted by JAXA to develop pressurized rover, but we will do our best to develop the safety and reliable pressurized rover. After that, it is happy if we can challenge. If we'd like to challenge to develop the next Mars mobility, please.
Excellent, and that is a perfect way to end it, and I think we're also perfectly on time. And the challenges of the future, right? So to the future, to the challenges into US-Japan collaboration at the moon and beyond.